Hello, everybody. Thank you for having me here. So, the blockchain was born a few years back along with Bitcoin, but in recent years, we have discovered that it is old technologies and its value goes beyond the financial value of cryptocurrencies only. And that's why the blockchain can have an impact on a variety of industries, an horizontal impact that can change and improve some processes of our real world. But for this to be possible, it's important that we acknowledge that the blockchain is not here to solve all our problems. It's not here to be, someone yesterday during a talk said that the blockchain wasn't designed for enterprises. And this is indeed true, because the blockchain, it's very complicated and doesn't fit all our use cases. It's not a solution for everything. And it shouldn't be the industry trying to change the blockchain for it to adapt to it, but it should be the industry changing to adapt to the blockchain and being able to leverage it in the best way. So 3 features that we can have thanks to blockchain applications are transparency, automation, and security. So we can, thank you. We can see here 3 different examples among the multiple industries. So we have a travel insurance, a financial instrument, and a bank 2.0. So a revolution in different industries, and all those 3 use cases are very different between themselves, but they all share a need for data. So let's take the travel insurance use case. We can have an automated payout as soon as our flight is late, thanks to a blockchain application. But for this to happen, the blockchain application needs to access the information about the status of the flight. So it needs this information. And so blockchain applications, as soon as they recognize a need for data, they face a limitation proper of decentralized protocols. So the blockchain, because it is a decentralized protocol, has an inherent limitation. So blockchain applications cannot fetch data coming from the real world and the internet and web APIs by themselves because of how they are built. So in order to solve this issue, it born the concept of oracles, blockchain oracles. So what we do at Oracleize is implementing a blockchain oracle. And Oracleize, it's the world's most widely adopted blockchain oracle. It works today. It's out there since 2015. And we already have blockchain applications using our service, both in testing environment and in production environments as well. We are integrating with different blockchains, and we do provide this connection for blockchain applications to be able to retrieve data coming from the real world. So as soon as we are implementing a blockchain oracle, we have to recognize that we are indeed adding a new intermediary in a world that tries to get rid of them. So it's important that we acknowledge that one of the main, two of the main features of blockchain applications are security and the reduction of trust in third parties. So as the data in our use cases is used to trigger a payment, so we have to be sure that the data was not compromised, and we can't trust an intermediary, we can't trust us, which we are a small startup, on our data, which can trigger a payment of 1 million, 10 millions. So what we need is more security. And that's why we developed the concept of authenticity proofs. So authenticity proofs are cryptographic guarantees, mathematical guarantees, proving that a certain data was not tampered with during the delivery. This means that those authenticity proofs are based on another technology, which is the one of attestation techniques and trusted computing. Thanks to this other technology, we can leverage those attestation techniques which are provided by a variety of parties that we call attestators. Those parties are Amazon, Google, Qualcomm, and all those big IT companies. So in this case, what we are doing is not trusting Oracle eyes for our data, but we are indeed trusting those attestators. So we are moving the shift from a small startup to a bigger entity. And not because the entity knows the data, but because this entity is the provider of the technology on top of which authenticity proofs are based. But again, maybe we are fine in trusting Amazon when the payment that we are triggering is, I don't know, 50,000 euros, but maybe if we are triggering a payment of 100 million, we are not fine in trusting Amazon alone. So that's why we went further to that, and we tried to implement a system that reduces the level of trust to a very minimum amount, so that we can have a system that per se cannot be completely trustless, because when we go from a decentralized protocol to a centralized entity and source of data, we have an inherent shift from a decentralized to a centralized protocol. So it cannot be completely trustless, but we can reduce the trust to a minimum amount. So what we have done is not just building one authenticity proof, but it's building many different authenticity proofs, each of them based on a different attestation technique. Each of those attestation techniques produced and manufactured and provided by a different entity. So for example, we have Amazon, Google, Qualcomm, Ledger, and we will soon have Intel and maybe Microsoft at some point. So what this means, it's not that we have like relationships with those companies. We don't have legal agreements with them. We just leverage their technology so that we can have a higher level of security and a reduced level of trust. Because in case, to make it very simple, in case an external attacker wants to compromise the data triggering the payment from your smart contract, it would need to compromise the securities and the technologies, all of them, in the same way and at the same time of all these different parties, which we believe it's pretty unlikely to happen. And also, we prevent an internal attack from us, because again, for us to be able to compromise your data, we would need not only to compromise the data, but we would agree with all those different parties who have a huge reputation at stake in compromising the data in the same way at the same time. So in general, when we deliver a data to a smart contract, we attach those authenticity proofs. So we indeed have a mathematical guarantee showing that the data is authentic and was not compromised. And this, it's very important, and we think that blockchain application will have a huge impact on the real world. And we think that when we combine blockchain technology and blockchain applications with this other technology, the one of attestation technique, it's here that we can build even more powerful blockchain applications, and we can have a real impact on a variety of industries. Thank you.